So yesterday, you have the rules in your notes. I'm going to refer to them, but I'm not going to keep flipping back and forth. The ideal thing is to get them in your forevers and be able to have them in front of you as we cover all sorts of new rules in Chapter 2. This is just the beginning, but this forever card has the most all at once. So, for letter A, how did I rewrite? I changed the cubed root to be the 1 over 3 power because it's x to the 1 in the cubed root. So this is now the power rule. Technically the constant multiple and the power. I think we took this derivative yesterday. I just want to make sure that you guys are okay. So at this point, when we get to differentiate, now it's time to do calculus. Now it's time to take a derivative in all of the examples. Once we rewrite, and sometimes we need to write a couple times. This one we actually rewrote twice before we can take a derivative. And we'll talk about him when we get there. But once we rewrite, if necessary, then it's time to take a derivative. So the constant multiple rule says this 3 just chills. Now, to be honest, I kind of like having the 3 chill there, and I bring the 1/3 to the outside. It's easier in my brain. Some of you, according to the constant multiple rule, you might write it a different way. But I like bringing the power all the way out, and I just realize I need to multiply it. And then what do I do with the power? According to the power rule, I bring the n down, and then I decrease by 1. I subtract 1. Now, yesterday, what did we talk about? Because mental math, some of you, this is super hard. 1/3 minus 1. How can you rethink or rewrite 1 to be more helpful? You can rewrite it to be 3 over 3 or 5 over 5 or 7 over 7, whatever is applicable. But you can think of it as minus 3 over 3. This is a mental math trick. And then you can say, okay, 1/3 times 3 is just, I'm just in the simplifying phase, is just 1, right? I'm going to have x to the negative 2/3. And is that an appropriate answer? I would say yes. However, in a lot of these, I'm going to write the word or, and here's why. Do you see at the very beginning, was this written in exponential form or square root form? Was it written with the power or with the root? So the struggle is almost always, not always, but almost always, whatever form you start in, the answer is going to end in. And that's not so much, this is still right, perfectly correct. But if this was a multiple choice question, I can almost promise you this would not be an answer. What would be an answer?
1 over
the cubed root
of x squared.
That would be the answer. So I'm just trying to help you make it match. In calculus, sometimes it's almost as hard to make it match as it is to get the answer in the first place. Sometimes, not always. But do you realize these mean the exact same thing? The negative popped it in the denominator. The 2 means x squared, and the over 3 meant the cubed root. Okay? So I just rewrote it this way because I know usually that the answer is in the same form with a radical as the beginning. Now some of you are like, wait, pre-cal, I can't leave it. Stop. This is calculus. Ain't nobody got time to simplify or rationalize. Doesn't mean that we couldn't, but I'm just letting you know, rarely do they worry about roots and denominators. Ain't nobody got time. Okay? All right. How did I rewrite this one? X was in the denominator. I was able to make the exponent negative. So how are we going to solve our derivative?
Power and the 1 and the constant multiple.
Good. So the 4 is going to chill, constant multiple rule. The power rule says bring the negative 2 down. I'm just showing you how I think of it. It helps my brain work. The negative 2 comes to the outside. Some of you already are like, oh, it's going to be negative 8. Good job. You're right. You're already getting faster at it, which is good. It's time to rewrite. Negative 2 times 4 is going to be negative 8, right?
Mm-hmm. Negative 8.
X to the?
Negative 3.
Careful, yeah. Negative 2 minus 1. Think on a number line. Negative 2, take away 1. I know you guys should know this, but I'm just trying to say a lot of people still make mistakes with subtractions and negatives. Negative 2 minus 1. Negative 2 plus a negative 1 is negative 3. Can you guys tell me what other form I'm going to write?
Negative 8 over x squared.
Yeah, is that cubed? Does that make sense?
Yes.
Because they might have it written in the same form as the beginning. Tyler?
Well, most of like the answer choices be in like
Similar
highly
forms?
simplified or just like
They should be
minor
in similar
simplification?
forms, but there could be every now and then something like this that is negative 1/3, and then you have this one, and that you like this form because that's what you originally found, so you might go towards it. Just make sure if it's written in, if you've thought about the different forms it can be, if it's written in a different form, you just got to make sure it matches. So every now and then they might show different forms, but for the majority of the time, you can kind of look at the answer choices really quickly and be like, oh, I see radicals, okay, let me rewrite it, now let me check. That's probably the safer way rather than just trying to look at this and see which one, I don't know, our brain doesn't always process well. Can someone explain to me how I got 3 halves? I did it really fast yesterday.
Okay, so the x, the square root of x is 1 half, and then 1/2 times, because there's basically a 1 power over the x, so you could say it's 2 over 2, and then you multiply those two together. You add the two together.
Good. If I have like bases, I add the exponents. So you can think of it as 1.5, or as Sean said, I can think of 1 as 2 over 2 plus 1 over 2 would be 3 over 2. Why did I do that? Power rule, it's ready to go. Here, what do? I even don't know. But as soon as I have it written like this, sweet, power rule. So we bring down the
3 halves times 1.
Now, some of you are doing the mental math, that's good, but walk me through the process. Some people need to do it
minus
slowly.
2 over 2.
Minus 1, which will be 2 over 2. Pause. Remember, we always take away 1, but sometimes it's easier to make it like 2 over 2 or 3 over 3 or 2 over 4. Then if I rewrite, I have 3 halves x to the
1/2, which would be rewritten as the square root of x, so 3 halves times the square root of x.
Right? Just 3 halves times the square root of x. Because the 3 halves is to the first power. He's not to the 1/2. You guys seeing how rewriting is going to be kind of important? Just rewriting the function before deriving is going to make the rules able to be used. And guys, there really is no shortcut for this one. There's a long cut for this one. There is a rule that will help you do this longer. That's annoying. There's another rule that will help you do this one longer. This is how to do it shorter. You gotta rewrite and then you gotta go for it. Letter D. There is a rule that would help us do D differently, but for right now, we'll just say the only way that we can solve it is by splitting up. Now, some of you got a little confused as to what I did here. Technically, what I'm doing is being totally legal, not killing a kitten. I can't just cancel out those x's because the 4x needs to be divided and the 1 needs to be divided. My pre-cal kids from last year, we talked about splitting these up. But if it helps, another way of thinking about this expression, just in case it helps, is 4x plus 1 being divided by x over 1, which means being multiplied by the reciprocal 1 over x. It'll result in the same thing. So whether you think of I have to divide each term of a polynomial, each term of an upper function by the lower function, we would actually call it Hart method last year. You gotta divide both pieces. Or if there's 3, it's a triple
Can you
Hart
only do
method.
that for addition?
What?
Can you only do that for addition?
Addition, subtraction.
It's hard.
Addition and subtraction only. What? Anyway, so, bring back. You guys know WoW? Anyways.
I just got that.
You're welcome. So anyway, either way, you have to divide each piece by it if you want to think of it as multiplying by the reciprocal and distributing. That works also, but either way you get to, the x's cancel on this guy. So I just have a 4, but this guy, x to the negative 1. Now how do I take the derivative of 4, cool kids? Derivative of any constant is 0. That's the constant rule.
Oh.
And then power rule. Bring down the negative 1, x to the negative 1 minus 1, which would end up being
Negative x to negative 2.
negative x to the negative 1 plus negative 1 would be negative 2. Or,
Negative 1 over x squared.
yes. Okay, pause. If I lost anyone on any of these examples, please, now is the time. Did I lose anyone? Do you need me to explain it?
Why does he be 0?
Ah, you can think of it 2 ways. There is the constant rule that says, for this guy, the derivative of any constant, this is the rule, is 0. But the other way, if it helps, if you get this whole power rule, you can think of this as x to the 0. 0 comes down. So either way works. Either way works. Sean and Sarah, have a great time. This will be fun.
Back.
Yeah, we're coming.
We're coming back.
Love you
We're not dead
kiddos.
forever. Have fun. Make sure the video is interesting to watch.
We'll try. You'll hear all their competition.
Oh, shoot.
Any other places?
I don't do competition.
Okay, anything else? Alright. So let's go ahead and see what other notes. There are some examples. I'm going to come back to those actually in a second. Let's actually finish the notes up really quickly. I think, yeah, that's it. This is our last page of notes. Then we'll do 2 examples, and then it's time. time for you to
It's
practice.
time.
We're gonna practice in groups. And so to that end, when it's time, when it's time, I'll have, making Denise on, I'll have you go ahead and absorb Crystal that way.
So we're
She's not on her own, because her group just left. Have you guys seen me use this line? You have, right?
Yeah, he showed us that once. He showed us what it looks like on the
I
old
showed it
calculators.
like once or twice. Good, good. So we're just writing it down just in case. Special notation. To find f prime of A. Now, as you guys are writing, aren't there like two limit definition ways of finding f prime of A?
Yeah.
Yeah, but this is talking about, well, now that we have these shortcut rules for f prime of x, it's gonna be easier to find f prime of A by finding the derivative with the shortcut rules and then plugging in. Does that make sense? It's gonna be easier, it's gonna be shorter. Before, maybe it was shorter to do the limits with f prime of A, then the limit definition of f prime of x and plug in. But now with the shortcut rules, it's way easier to find the derivative and then plug in. And once again, what are we finding when we find the derivative? The slope of the tangent line. Or, as we apply it in section, I think 2.3 is where we start applying it, the rate, the instantaneous rate of change. All right, you guys got it? Okay, can we do two a little bit harder examples and just see how we do?
Sure.
All right, so let's go back.
Oh, all right, here we go.
Oops, sorry, this way. Just you, yourself, and you, not get competition. I want you to try to solve these two examples. Just name it one, name it two, okay. We'll make one of them an f prime of A. We'll make one of them an f prime of A. The directions are just to find the derivative. My hint would be rewrite. And then try to use the rules. You guys ready for me to unveil? Is that how you rewrote it? Now, I went fast on my next step, so check your work. Did I bring down, first of all, is the rewriting okay?
Yeah.
Second of all, what rule did I use to keep going or to take the derivative? Power rule on both. Good. And so power rule, remember, and just for some of you, because some of you haven't gotten the rules down well, some of you just remember them and that's okay, but some of you are like, I don't got it yet. Bring down the power, take away 1. So, did I bring down the 1/2 for x to the 1/2? Yeah. How did I get negative 1/2?
-1.
Good, 1/2 minus 1 is minus 2 over 2, right? So 1/2 minus 1, take away 1, take away 2 over 2, that's just gonna be a negative 1/2. That's how I got that. 1/2 minus 1 or 1/2 minus 2 over 2. Did I bring down the negative 1? Yeah. How did I get negative 2? Negative 1 minus 1. Negative 1 plus a negative 1 for negative 2. It goes more negative.
What's the?
Then, Why is my square root in my denominator?
Because.
It's a negative, and it's a 1/2 power. So negative in the denominator, 1/2 is the square root. -2 came down in the denominator. How do I finish my problem now? Yeah. Another reason that I changed the notation, how many of us are good at raising 1 to the -1/2 power?
Yeah.
But can we plug 1 into a square root in the denominator? So we end up with 1 over 2 root 1 minus 1 over 1 squared, which is 1/2 minus 1, which is, can you do this mental math a little bit quicker now? It's 1/2 minus 1.
Might be.
-1/2, because you just subtract 2 over 2, which is -1. That is, this is the equation of all the slopes at all the different points to this guy. This is the slope of the tangent line at x equals 1. So let's do number 2 all together so we have plenty of time for practice. But Austin, go ahead. Any questions?
I'm kind of confused with how you got 1 over 2 at x.
Did it make sense where the -1/2 came from by subtracting?
I get that, yeah.
Cool.
I get that.
Then we have to look at this. The negative says just his base, which is just x. 1/2 is like to the 1 power. He's his own deal. There are no parentheses.
Yeah.
So 1/2 just stays himself. 1 on top, 2 on bottom. But x, the -1/2 says you belong in the denominator. The 1/2 says with the square root. So the negative pops him down. The 1/2 says you belong with the square root.
Why is it when you, from the 1x, it becomes x to the power of -1?
Oh, because it was x to the 1 in the denominator, and so since it was in the denominator, I can pop him up and give a negative x.
Okay.
Yeah, and then I had to take away 1, -2, which popped it back there. How would you rewrite number 2? Why do we need to rewrite? Do we have a quotient rule? Not yet. Not yet.
So you just
So-
do times x to the
That's the
-1.
Which way makes more sense to your brains? Part method, just divide both, or multiply by the reciprocal of x over 1? Okay, so divide both. That's what I first heard. I'll show it both ways though. So I can do x to the 3/2 over x, and that's x to the 1, right? On the denominator? And then I'm gonna have plus 2 over x. I'm not done rewriting.
Divide and subtract.
Good. We practiced just a second ago multiplying 2 powers with like bases. We add, but when we divide, we subtract. In mental math, how can we subtract 3/2 minus 1?
2 over 2.
Yeah, I can do minus 2 over 2, just to help it. So it'd be 3 over 2 minus 2 over 2, which would be 1/2. The other way is that you could change 3/2 to a mixed number. And it could be x to the 1.5 minus 1, which would just be a half. Either way you think about it. And I'm going to change this one to be 2x to the power of -1. Now it's set up ready for me to take a derivative. Why am I writing dy dx if I wrote f prime a second ago? Do you guys see why I chose to write f prime? What do I have to begin with? I use f prime when I start with an f, and I use dy dx when I start with a y, just so that you can see how those notations go together. You could do y prime. You could do y prime. Some people do. I don't like y prime all the time, because sometimes it can look like y to the 1, and it can get confusing. But if you realize when you have y within a box, it's always y prime again. I'm going to bring down the 1/2. 1/2 minus 1, 1/2 minus 2 over 2. I'm going to bring down the -1, so it's going to be minus 2, x to the -1 minus 1, -2. I didn't ask for at a point, so is this technically an answer for y prime or dy dx?
Yes.
But it's not a pretty answer, right? The better answer would be, well, you guys, tell me what's going on.
2x. That's square root of x.
Square root of x.
Minus 2 over x squared.
Now here's where I'm just going to give you a peek as to why I said sometimes the simplifying is harder than the solving. what could they do if they see two different fractions with the minus? They could do common denominators. At which place this guy would need the x squared. So it would be x squared actually you wouldn't even need x squared. You could just multiply by
X squared to 2.
x to the 3 halves if you want to be really stinky. It could be really stinky and just multiply by x to the 3 halves minus 4. Oh, that'd be mean. And how'd they get that? They multiplied this guy by 2 over 2, and they multiplied this guy by x to the 3 halves over x to the 3 halves. Because we already have a half, we only need 1.5 more to make a squared. That was really mean. But here's where you just see a peek at how sometimes making it match with their answer might be even harder than solving. This is that, is that.
Can we do it the other way?
What other way?
Oh.
The quotient rule way? No.
Oh.
E for effort. All right, cool kids, it's time. We already took those notes, and it's time for us to practice. So I want one person from every group to come get a white board, it's not a board, a white paper, and a rag, and a marker. And then if you guys can go ahead and clear off that desk and let.
Oh, Miss D, no,
Krista,
what I
please.
did? I did x to the 3 halves plus 2 times x to the negative 1. Is that one? If it's over x?
That's valid, but I would pretty much say you would never see an answer stated like that. Just because that's ultimately a fraction, they usually show the fractions. All right. I'm going to have you come on up and join this group, that way you guys can all be one. Yeah. Kiddos, if I were you, I'd kind of turn your desk. We still have like 15 minutes, 14, 13. So turn your desk, that way you can see. We didn't do this a lot in pre-cal. We're going to do it in calculus whenever we talk about new rules. You are allowed to have your basic rules open if you would like. Some of you think you have them memorized, and that's really cool. But you can have them open in your notes, or I would say even better, in your forevers if you have them copied. You can have the basic rules open. Here's the rules of the game. For today, the name of the game is not speed, it's get it right. The name of the game is not speed, it's get it right. We're going to go ahead and have your guys' group numbers up on the board. So we have group number 1 represented, 2 represented, 3 represented, 4 represented, and 5 we're just saying is gone for today. Because they left. And then we went ahead and joined. When we solve, quick heads up, if you leave the cap off the marker, he dries out really fast. Just so we're not doing anything, just keep it on. But when we solve, one person needs to start with the marker in the whiteboard. And once they start, they are the only person who is allowed to write anything on that board. But the rest of you can talk them through what to do. Okay? So whoever has the marker, they're the ones that have to write. But here's a quick heads up. The next problem, we switch. They cannot hold on to the markers. So everyone's going to have a chance of solving problems. And we're just going to keep on going around. No double turns. No sneaking it back to the person who's getting them right all the time. None of that. Here's one more thing. If this is you guys being able to practice, if it's not for speed, if it's for correctness, should I have the person that can do the derivatives quickly in their head just randomly shouting out answers?
No.
That's not helpful for your group. Does that make sense? It's not for speed, it's for correctness. And this is for you guys working together and working on your weaknesses with these new formulas. So, anyone who's talking and trying to help, you can be saying rules, you can be saying steps, you can be saying, hey, doesn't this come down, doesn't this? And you can be asking questions. As a group, you're trying to get better. Does that make sense? All right, you guys ready?
Ready?
Can you go to the bathroom?
Yeah, she'll be back. We'll go ahead and start. And she can see, it's on the video, so she can see what problems we're doing. All right, number 1, here we go. The directions for all of these are just find dy dx. You can also say y prime.
Just a right.
You need to write the problem first. Ooh, it's a bad one, just toss it. See if that one's better.
Good shot, David.
Okay, so you have to write the problem first, and as soon as you finish writing the problem, you can start solving. But I need a dy dx or a y prime equals. Here we go. y equals, we'll do an easy one, 4x squared plus 3x minus 11.
Okay. You got that.
You can show as much work or as little work as you want.
How do you get there so fast?
Once you guys
I get too close.
think you have your answer, box it and hold it up.
Oh.
Once you think you have an answer, box it and hold it up. I'll give points accordingly.
Gosh, this would be embarrassing. Right? I mean, that's good.
Hold it up.
Oh. Wait. Oh.
We're getting two.
Can I raise?
2, and then x to negative.
What did you ask? It's a
Oh, 4.
Can I raise? Yeah.
Yeah, you can erase once I've marked down.
I got it.
Okay.
Alright, do we want to just go in a circle?
Yeah, we'll go
Do we
in a
care what direction? We'll go this way. We'll start the circle.
Zach, are you helping?
Yeah, but then this one's
So much neater. Oh, just erase it.
Thank
There you
you.
go. If you want to make your 2 absolutely perfect.
Just gotta get it right.
See what you got.
When you ditch 13.
I'm sorry.
Let me check it. Okay, group number 4, who had it? Tyler, you had it. Explain how you found it.
Oh, you just bring the 2 down, multiply by 4, so you get 8x, and then subtract 2 minus 1's, then 1, and then do the same for 3, which is 3 times 1, and go to 0, so the x turns into 1, and then the 11 turns into 0. I don't know.
Because the derivative of any constant is 0. So 8x to the 1 plus 3x to the 0. X to the 0 disappears, but 3 remains. Does that make sense? Does that make sense? So we're using our power rule. So we're using this one. Bring down the power and then subtract 1. Does that make sense? Alright, let's try another one. What if we were to do, new person, right? New marker? Sorry, not new marker. Number 2.
Yeah, I know we had it, but.
What if we say y equals, ooh, ready? Shouldn't have had your rules on this one. Let's do negative x to the 5th plus 3 cosine of x. It's okay, have the rules close, have the rules.
Yeah, but you just do them separately, so it's negative 5x to the 4.
It's just a positive.
Yeah, and then shoot, I don't know the rule for, do you have the rules, Tom?
Yeah.
And then,
Minus.
Oh, that's
no, it's cosine is negative sign.
cosine of x
So then,
It becomes.
Now check, there's a whole group under here. There's the whole group under
I
here.
think,
When you're ready, hold it up.
So,
Nice job.
what's the?
get around the circle, get around the circle. I don't know the trick, so,
Does that make sense? Good. Alright, let's check it. You guys agree? Bring down the 5, it has a negative, 5 take away 1 is 4. And then what is the derivative of cosine?
negative sign.
Negative sign, so the 3 remains and then the negative sign and then you're done. Alright, new person. Go ahead and erase it and new person. Ready? Okay, number 3. Y equals, you ready for this?
Right.
Alright.
Can you get spicy?
1/2 x squared times the cubed root of x.
Okay.
So,
Rewrite first.
oh, you should,
Rewrite first.
1/3. Sorry, that it's 1/2 times u squared times x to the 1/3.
Oh, do it with you.
Because that's what you do. So then you do 1/2 x squared x to the 1/3. What is that? 7?
Well, is this?
And then
I want to say
divide
it's
that
There is that.
pretty much.
Would it be one? You can, I'm thinking we could just compile the x into one.
Yeah, yeah.
So that would be 7x, or 7,
Yeah.
7 thirds? No. I think it's 7, no. Because what if I don't actually know if you can.
Oh, God. 2 times 1.
Yeah.
And then so it becomes, because that's just one.
But I don't know if you can do those separately. I don't know if you can.
And so that one.
It's just, I don't think there's a rule which justifies this.
Oh, in terms of.
This one, you can only do it if they're separated by addition.
Talk him through it though, guys. You can help him step by step. He doesn't have to be
What's
alone.
2 plus a third is 2 and 1/3, which is 2 and 1/3.
Now can you rewrite it?
6 thirds, and then that's 7 thirds. So it's x to the 7 thirds.
So it becomes.
Oh, yeah. It's 1/2 x to the 7 thirds. That's not the y x, that's just x to the 7 thirds. And so should be break it down to 7 thirds. 7 thirds times 1/2 times.
So the x.
Like, do you get what I'm saying?
-1.
Oh, and then 1/2 goes in front of it.
Like, that's the power of it.
I just compiled the 1/3 and the x squared into one.
Okay, cool.
So 1/2. So then, when we actually do the rule, we subtract
Basically what we did
from
Right.
down to
First, before taking the derivative.
x to, like, x to the
So you rewrote, that's good, but you gotta put these together.
For subtracting the power.
Oh, yeah.
So it's x to the
This is x to the what power?
So x squared.
1/3.
Yeah, so do
Yeah,
the
Is
1/3.
also x
This
squared.
might be wrong, but if
Because
it's
x to
right.
the
And then
1.
you do
Yeah, how do you
1/2
put x
times
squared and x to the 1?
7.
Putting it in this, and then when you multiply.
You could say 2 and a third.
When you multiply powers, you
How would you write that as a
7/6
fraction?
x to the 6/3.
17/6. That seems right.
6/3.
So rewrite this as 6/3, just to make
I
it easy.
think.
And
And then when you multiply by bases, what do you do to the powers?
What was it? It was
So it's gonna be x to the 7 thirds.
3 times 1/2.
Now it's time to take a derivative. Now write d by dx. Now use your rules. Does
Do
that
you
make
see?
sense?
Do you see what I'm trying to do, Sam?
Yeah.
So the 4, so this is right here.
Make sure it's
When you're
you're
bringing down.
right.
That's, oh, and then,
That's good.
It's always gonna be 1/4.
not 16/7, it's 16/4.
So 7/3 minus.
This is probably not gonna be an answer choice on a multiple choice test. I might have, is that valid? Can you do that with the x's? Can you add
You
your
bring
exponent?
down this number.
Yeah, this is good.
So
You said take the derivative of that.
Yeah, and then I forgot my number. So what?
Oh, you need to do derivative. Hold on.
Subtract minus 1.
You already took the derivative from here to here, because I think you subtracted 3.
Yeah, but then there should be a number in front of that, and I just had it, and now I lost
It's okay, write
it.
it.
16 over
Isn't it
something.
7/3?
Oh, can I actually just,
times
do I have to simplify? Oh, well, I guess that makes sense. Yeah, so it
So
is 7 over 3 times 1.
here, the 7/3 comes down, so it'd be 7/3 times 1
So
over
1/2 becomes 0, this becomes 0. Because the power of
down, and then multiply. And then take away 3/3. Good. So just simplify fraction. What's 7
I don't know.
over 3 times 1 over 2?
Is it 17 over, no, it would be 8.
Oh, except 2 times 3 is?
Becomes 0.
I don't know.
Oh, constant
Oh, yeah, it is
1/2
7/6.
squeeze. Okay. Alright, kiddos, good job. Almost everyone got to use the marker?
Yay, Tyler got a point on the last one though. So we
We
win.
got a point.
Our group
All you do
wins.
is erase and just put this supplies back where you found them, maybe someone gave you the originals.
Oh, come on! It's a tie, Misty.
I'll give you 2. Bye.
Steve, 4. Can you give me 3?
Oh my gosh, it took.
But it's okay.
If I don't want my stampede wrong, what's
So you don't remind me.
Okay.
So Charlotte, you can just come in a couple extra times. It's okay. Austin, listen.